Hello everyone, in this video we're fixing a broken marketing engine inside an e-commerce checkout API on Develow.com. Currently, when a customer submits a promotional code, the backend silently accepts it without throwing an error, but it never applies any mathematical discount or shipping modification to the invoice total. We need to jump into the Develow IDE, leverage our DVL AI chat to parse our route parameters, and implement a secure server-side promotional rule set. To execute this fix cleanly, let's turn to our DVL AI chat to get a map of our local metadata variables. Demonstrating structured layout discovery using precise prompts is highly valued by interviewers checking your prompt engineering skills on Develow. First, we prompt the AI. First, let's find the data models. How are valid promo codes and their discount configurations configured in this application? DVL points us to an internal global catalog dictionary called promos. Next, we trace the route lifecycle by asking, where are the API routes defined for handling the post-promo request? DVL directs us straight to the apply promo handler block inside API/src/store.js. Finally, we establish our guardrails by asking, what do the tests look like in test/promo.test.js? The AI confirms that unknown codes must break early with an HTTP 422 error. Let's build our engine. The architecture requirements for this fix demand clean structural mapping and strict mathematical bounds. We need to build a system that handles three completely distinct classes of promotion types. Percentage discounts. Save 10 must deduct 10% off the current subtotal, using proper rounding for integer cents. Fixed discounts. 5 off must deduct a flat 500 cents from the cart value. Shipping overrides. Free ship must drop the base shipping cost down to 0. Crucially, the server must run these checks before returning the cart state, clamp the maximum discount value so the grand total never flips negative, and cleanly throw an error if the user enters a non-existent code. Let's open API/src/store.js and build this out in 2 quick steps. First, let's scroll down to the apply promo, open parenthesis code, close parenthesis, input handler. The old code was silently passing everything. We completely update it to reference our promo's constant lookup dictionary. If the code is absent from our catalog, the thread breaks immediately, passing back an explicit 422 error status block. Otherwise, it attaches the coupon object directly to our state tracker. Next, scroll back up to our cart snapshot calculation block to process the values. We extract our applied promo, initialize a discount collector to 0, and set a free shipping Boolean flag to false. We construct an if block checking the structural type property of the active promo. If the type matches %, we compute the fractional value and wrap it in math.round. If the type is fixed, we assign the raw currency integer value directly. If the type is free ship, we flip our tracking flag to true. To prevent financial exploits, we instantly clamp the valuation by writing discount equals math.min open parenthesis, discount comma subtotal close parenthesis semicolon. This guarantees our discount never exceeds the subtotal cost. Finally, we use a ternary operator to dynamically assign our logistics layer. If free shipping evaluates to true, shipping becomes 0. Otherwise, it calls the base shipping calculator. We map these fresh fields directly into our grand total calculation payload block down below, and our server math is perfectly secure. With our validation code and calculation block saved, let's bring up the integrated terminal window right here in the Develow IDE to verify our solution. We run our tests. The test container executes across a variety of valid inputs, validation checks, and rounding limits, and everything passes successfully with full credit. Centralizing your pricing calculations on the server layer and validating lookup codes against structural dictionary models ensures a highly robust, secure checkout workflow. By leveraging the DVL AI chat to quickly analyze internal promo objects, we successfully implemented this engine with minimal friction. This ticket is now resolved. Bye for now and see you in the next code challenge.